Hello and welcome to the third part of our three-part series, Getting into Scanning, this part specifically looking at office workflows. This series has covered scanning from the beginning through to the end, and if you've missed our first two parts, I recommend going back and looking at them. The first part being Scanning for Beginners, covering the basics of scanning, looking at terminology and some of the different registration techniques that can be used for fitting scan data together. The second presentation being Scanning Best Practices, looking at field considerations for successful scanning projects in the office, and that would help the data workflow into the office presentation, which we're going to look at now. The processes discussed in these presentations are relevant to all scanning projects and manufacturers. However, Trimble scanners and software will be referenced throughout this presentation. Specifically, we will be looking at Trimble RealWorks, but mostly Trimble Business Center. So let's start off looking at scan data projects in general. Due to the large number of points that are collected, a point cloud quickly accumulate in size in the field and become quite large in the office as well. So storing, transporting and sharing point cloud data need to be a strong consideration when looking at any scanning project. As point clouds are handled as a single entity, so that meaning that if you click on a point in the point cloud when it's been imported initially into Office software and all the points in that scan will be selected, tools in Office software can be developed to make processing easier, such as the Extract Classified Point Cloud Regions tool in Trimble Business Center. Algorithms are a central part to the point cloud processing process. So you will be coming across a lot of algorithms when looking at processing point cloud data, no matter what system you are using. Not all packages are designed to handle point clouds or are only capable of handling small projects. So just be aware of any limitations that might be set out within the manufacturer constraints of some packages. With regards to Trimble Business Center and Trimble RealWorks, which we'll be specifically looking at in this process, the machine specs are going to be your limiting factor. There is no hard limit to the number of points in a project or the project size. So let's introduce some new points of terminology that we can add to our list that we accumulated in the first presentation. When looking at data that's come into the office, it can be handled or exported in two main ways. You can have an unstructured scan where all the points are handled as a single entity. In an unstructured scan, you cannot individually turn on and off each separate scan. So when you've downloaded raw data into the office, you can see that you can turn off and on individual scans. If you export an unstructured scan from Office software, it is just going to be the entire point cloud. You can't have any single setup or scan station information associated with it. When looking at a structured or gridded scan, those setup stations are exported as well. So when you download data into Office software, it is considered a structured or gridded format, allowing you to turn on and off individual scans as required. When exporting data, it should be a strong consideration to note whether the export needs to be structured or gridded, in which case only particular formats out of Trimble Business Center and RealWorks will support that, and that needs to be selected as an option when exporting. There are also some industry formats that need to be considered. So if you're unfamiliar with scan data, it's worth noting that the industry standards for point cloud data are E57, LAS, LAS, RCP, and points, as well as a couple of others. These are all handled by default in both Trimble Business Center and Trimble RealWorks. 3D PDF and CAD formats such as DWG and DXF are not recommended to be used to export point clouds into or for handling point cloud data. They can be used for the CAD data that comes out of point clouds, however not for storing the point clouds themselves. They are not designed to handle the large number of points in a point cloud. Not all formats support structured scans either, so it's worth noting that Recap is a structured scan export, and in Trimble Business Center we have a specific option to export an E57 to a structured scan. In Trimble RealWorks, there is an option to export structured scans to E57 LAS, LAS, and points as part of the export process. When looking at Trimble Business Center and RealWorks, as mentioned before, there's no hard limit to the number of points, and the machine spec that you are using will dictate how many points you can handle. The more points in a job, though, the longer certain processing functions will take, such as importing the data and classifying regions. In this case, these processes are a one-off step and will only be needed that initial stage, and once saved, they will not need to be run again, as that process will be saved as part of the format. It's worth noting, though, for particularly large projects, it might be worth splitting up into smaller projects and working on smaller projects to help with speed and efficiency of data capture. When looking at Trimble Business Center and Trimble RealWorks, Trimble Business Center should be seen as a georeferencing and 2D output workflows, primarily. 2D being point and line, not just 2D. Trimble RealWorks should be seen as a 3D or volumetric output, and they are two very different workflows that can lead to those exports. Trimble RealWorks is also the only package at the moment where target-based registration can be achieved in the Trimble environment. Different packages have different point clouds tools. Trimble RealWorks and Trimble Business Center have a large number of tools, however, that overlap and are common between the tools as general import and setup tools for the projects. Generally, though, the point cloud tools will be some form of what is seen in the screenshot below, which it comes from Trimble Business Center. And they would start with registration tools to help tie and locate scan data together. Region tools, which can either be automated, as Business Center and Trimble RealWorks can do, to classify regions automatically, or it may be a manual process to some degree. Different view tools to allow you to view the data in different ways, such as 2D, 3D, cutting planes, limit boxes, station views to better see what you're looking for. Rendering tools are a big one for most point cloud packages. They will allow you to see data in the point cloud data in different colorizing techniques and also sizes. Then there are measuring tools that allow you to measure the different options, different points within the point cloud, and also deliverable options. So general outputs, or in the case of Trimble Business Center, some automation techniques for extracting different types of data from a point cloud automatically. When looking at Trimble Business Center and for Trimble RealWorks, they both work on a general left to right process within their tab system. So particularly in the point clouds tab, you can see on the left-hand side, it's importing data and handling that import and setup stage. When you go through to the right-hand side, you're looking at that output stage and getting data to that next step. The first thing when you download data into a Office package is the setup. So when you're looking at setting up a project, data can come from a package such as Trimble Perspective out in the field where the data has already been registered together, or it will need to be performed as a secondary process in the Office. This is where the registration tools come into play. Registration tools can also be used to break scan registration sets from, say, Trimble Perspective, where they are already linked together, to better fit the data or to address any registration issues as well. So they are not just limited to projects where the data has not been registered. There are different types of registration tools that can be used too. There's plane-based, which will use different planes to lock the data together and to try and get it to fit, or pairwise, which allows you to identify common areas in two different scans to help the system identify where it's matching the data to. To shift the data, it's an idea to have the control to shift into. So this being, you would need to import, say, a CSV file or DXF with your control points, and to shift the data using the georeferencing tools, you would select points in your point cloud to then shift onto your control network. Cloud-based registration isn't done on station-based projects. So this is a consideration when using the SX series of instruments. you will not be able to use the cloud-based registration on anything that has been done using a station-based setup. For this, it's because you have your registration is done against the setups, not necessarily the clouds themselves. Once registration has been done, a refinement should always be run to get the report out, as well as to do that final tightening of the network, considering all the data within the project. A refinement, as mentioned previously, can be run twice to help tighten it if there are still some small issues that might need to be addressed, and it can improve that second time. In the case of Trimble RealWorks, the target-based registration can be done as a part of the registration process to link the scans together. Where possible, real-world coordinates should be used in the field. So in the case of station-based setups, tying to control to allow your network to be in the right location and rotated in the right axis should be an important consideration for any scanning project. Wherever possible, in the use of something like Trimble Perspective, you should import coordinates and tie those coordinates to points in the scan data in the field. So once the data is in your desired package, such as Trimble Business Center, it's in its correct location and you can continue working along. Scale factors are a consideration for scan data. So for long linear scanning projects, shorter sections may be needed to account for scale data scale factors if it is going to be a consideration over a long distance. Also shifting data, it needs to be considered that scale factor may become an implication. So it's always worth noting what package you're using and how that package handles scale factors and what you need in your processing before fully undertaking a scanning project. Wherever possible, it is recommended to keep the data close to the final setup of the output of the project. So in the field, and if you're referencing in the field, you do not necessarily need to set up on physical control or known points, but if you can shift the data into a location that is generally within the right ballpark, it will help the onflow of data and processing down the track. Shifting of the data onto datum for point clouds should be done after registering and before digitizing. So when you're coming to digitizing data, it's recommended to make sure that the data is digitized in its correct location so that there are no potential issues that might arise from shifting the data. And when shifting the data, it's important to note that all data should be checked once shift, and it needs to be checked against points that you might know, or to ensure that the data is exactly where it needs to be and within the tolerances that you have as an organization. In TBC, projections can be used for positioning and scaling data once imported. Station-based registration needs to be done using the Transform Survey Points tool, whereas cloud-based registration needs to be done using the Georeferencing scan tool. So by this, because if you're using an SX series instrument, because you know the setup of the location of the scan data and it's done using the stations, not cloud to cloud, we will shift the station location for the scan data rather than the scan points themselves, because the scan points are calculated against where that station setup is. So for this in TBC, you would use the Transform Survey Points tool, which is in the Survey toolbar. For the cloud-based registration, so if you've just got cloud data with no setup, say coming from a TX series instrument or an X7, the Georeferencing scan tool needs to be used to shift the data onto datum, and that's done from the Point Clouds tab. Colorization in scan data, while looking pretty, doesn't necessarily add a lot to the extraction process. So when looking at data in the office, colorized data can look pretty. It can give you some form of indication of what's going on if you weren't necessarily out in the field to begin with. However, when it comes to extracting the data, there are other tools and processes that can be used. So the colorization step is not necessarily fundamental to the process and can be done at a later stage. It can be done almost at the end if in some cases. Sometimes it can be quite time consuming, and it's worth doing in the field and imported into the Office software as a secondary process. In Trimble Business Center, it's recommended to turn off the colorization of scans on the import for SX series instruments. However, for X7 and TX series instruments, it's worth noting that the colorization step needs to be done on import. Colorization can be done on the SX series instrument, and also it can be recolored on any other data formats later after processing the panoramas and to help balance out the color and blend the edges, which can improve the quality of the output of the colorization process. So in TBC, there is an option that allows you in the point cloud tab to process the panoramas, which will blend the edges of each of the images that are that go out to form a panorama, and also can balance the color. And this can have an impact on the overall quality of the colorization step. And then you can rerun that against your point cloud to help improve the colorization. The big thing that we will probably need to discuss at this point now is the classification of regions. So once you import data into your package, the data is seen as a single entity, and we will call this a default region. That single entity is very hard to turn on and off. Well, you can't turn on and off individual sections, and to see individual things, you'll be using view tools such as limit boxes or cutting planes to isolate sections of the data and to sort of identify what's going on. The classification of regions tool within TBC and in RealWorks allows the data to automatically be broken up into specific regions. And these regions will allow you to then turn on and off subsets of the data to allow you to quickly see what you're specifically looking for in a project and narrow down into a specific area very easily. This step is fairly quick, and it will save you hours if you didn't have to do this and you were manually putting the data into different regions yourself. There are two different types of classification that can be done in Trimble Business Center and Trimble RealWorks. There is the indoor classification, where floors, walls, graded floors, and ceilings can be extracted from an indoor classification, and an outdoor classification where buildings, ground, high vegetation, poles and signs, and power lines can be extracted. In both cases, there is what's called a default region extracted as well. And this is where anything that can't be identified as one of those groupings is put onto. The classification tool is generally about 70% correct. And this is, it sounds like it should be higher than this. However, this gets you a significant portion of the way through the classifying and the processing of your scan data. And it's only minor tweaks that need to be made to shift the remaining data into their desired levels to help you get the desired outcome. When you're tidying up regions in TBC, we have several different tools that can be used in the Regions tab that allow you to do different things within the data. Generally, you're just selecting the data and shifting it from one region to another. So you go select the data using the polygon or the square select tool on the bottom of the view, and then you use your keep in, keep out tool to narrow down the data to a specific desired grouping, and then you would use the add to region to shift the data to a new region. You can create regions in Trimble Business Center and in RealWorks. However, these are not going to be automatically identified regions. So if you wanted to identify a car, for example, the create region tool can be used to create a car region. However, you would manually need to shift the data onto that region. The core classification regions that we discussed previously have algorithms behind them to identify those specific regions, and that's why they are there. It's faster to shift misclassified data than it is to manually shift the data to begin with. So I would always run the extract classified point clouds region when processing the data. The other thing to consider here when processing the data is that when you are extracting point cloud regions, the indoor scans should be isolated from the outdoor scans. And this would allow you to run the outdoor classification and the indoor classification on the relevant data. Running the outdoor classification on the indoor data will not necessarily give you a result that you may be looking for. And the same way, running the indoor classification on the outdoor data will have that same impact. So I would recommend splitting the data up so that you have your indoor scans in one grouping and your outdoor scans in another grouping, or indoor scans in one project and your outdoor scans in another project, and then you run the classification on the relevant regions. When we're looking at the keep in, keep out tool, the example here is the power line, the power pole, which is being classified as high vegetation, so green in Trimble Business Centre. On the right here, we have isolated the data there. We've selected around it, and we've selected keep in. And when you select keep in, what that will do is that will hide all the points that aren't selected, leaving you with only the points that are selected. This is just a visual tool, and it means that you can then rotate that 3D view into the area that you may that you want to be able to better see the data that you don't want. And you could select the data that you don't want and then use the keep out tool to hide that data that is not wanted in this selection set, to leave you with what you're wanting, which you can then select and then use the add to region tool to add that data to the region. So keep in essentially will keep the data that you have selected into the view, hiding all the unselected data, and keep out will hide the data that is selected in the tool, leaving you with all the data that isn't selected. Both the tools can be used multiple times to narrow down into a specific area, and then the add to region tool can just be used to shift the data onto a specific region. Another big consideration when classifying data is to not delete data. There are ways that you can delete data from both Trimble Business Centre and Trimble RealWorks. However, instead of deleting the data, it's worth just putting on a default data or a default layer or a rubbish layer, and turning that layer off visibly in the layer manager, and then it doesn't necessarily need to be a consideration. The benefit of this is that you can come back to it. It's very simple to get data out of a turned off region, and extremely difficult to re-import data and get you back to where you have if it's been deleted or accidentally deleted. Sampling tools can be used to copy points into new regions to help improve the classification of regions. So if you have a multi-story car park and you want to put a section of data into each of the floors of that particular car park, however, you also want to retain all the points in an overall grouping of the entire project, you can do that with different sampling tools. Filter scan points can be used to cut back data to a certain radius from the scanner to meet requirements as well. So you can say, I only want the data within a 40-meter radius of the scanner location, and the data can be cut back to that region, leaving you with just the area of relevance. There are some areas that require this to happen. However, it is worth noting this can be done in Access and in Trimble Business Centre and RealWorks. I would recommend not doing it in Trimble Access. Running your classification tools in Trimble Business Centre or Trimble RealWorks, and then running the filter scan points to get the data down into their particular regions, because the classification tool will work better with more data. So if you can extract and use as much data as possible in that classification tool, you'll get a better set of results when it comes to that classification process, and then you can just cut the data back from there. Another consideration here is that when running this in Access or in the field, it is not speeding up that processing. It is simply measuring the point, identifying whether it falls within or out of the range, and then throwing the point away in the field. You do not get to get that data back at all if it's run in the field. However, again, in the office, you still have that data in the background if you need to return to it for some reason. Again, as I mentioned earlier, splitting the internal and external scans when running the classification tool is recommended rather than applying it overall. So that comes into that internal and outdoor classification tool sets. And again, turn off unwanted classes in the classification regions tool to help hone results to the desired regions. So when we're looking at things like running the outdoor classification, if you only want to classify the ground, you can turn off the other regions, leave ground ticked on, and it will only classify the ground. If you want to only classify the ground and buildings, then you can do that. Anything that's not classified as ground or buildings will be just put into the default layer. This can speed up that classification process for specific needs, and it can become quite flexible, meaning that you're only getting out what you're specifically looking for in a project rather than having a whole heap of different classifications that you may not need. When specifically looking at Trimble Business Center, there are some general point cloud tools. Now, these tools can be and will be available in other packages, so it is worth noting that they are not just limited to Trimble Business Center. However, we will be looking at Business Center as the case here. So you can render the point cloud regions in different color processes. So you can look at the scan color. So this will show the point as a particular color based off the scan station that it was collected from and the scan that was captured at that station. This allows you to easily see the particular data, where it's collected from, and turn on and off individual scans based on a particular need. There's also region color, which we've looked at before, where you have the data colored as a particular region. We then have grayscale and color-coded intensity. On the right here, you can see the color-coded intensity. It looks very bright and vibrant. The way that scanning can show this is when you do a scan, the scanner measures not only the distance or the time difference between when it sends out the signal and captures the signal back to get that distance measurement, it also measures the strength of the return. So the intensity views within Business Center and RealWorks will allow you to see what the strength of the return is. And the benefit for this is that you can start to see things like bitumen, line marking, concrete in different ways, and it can really highlight different textures and surfaces within a project. This is not a recoloring of the true color. When looking at true color, as mentioned, it looks quite pretty, but the problem with true color is it's a secondary process. So if someone walks in front of the scanner when it's taking the images, they will be projected up against a wall. In the same case, if a person is collected in the scan data and they've moved when the imagery is captured, that person will still be there in 3D space as a capture in the scan data. However, when it's come to colorization, they're sort of a weird ghosted figure. The color-coded intensity is the results that have been captured as the scan was physically done. So it's worth noting that color-coded intensity is generally where you'll be processing your scan data from. It's easier to see different textures, it's easier to see different outputs, and it's quite easy to digitize data from color-coded intensity values. The final one is color by elevation, and this can actually, in TBC, have some good values to see how level something is to the ground, and it will color the data based on a range that is determined. So it could be 1 meter, it could be 0.1 of a meter, and the elevation is set to, it can be set to a non-zero value too. And this can allow you to see how the fall of a project is, the roof line of what is supposed to be a flat roof, or the fall within a concrete slab can be identified quite quickly and color-coded by elevation. Other tools that we have are point size. So you can see a small point size is 1 pixel per point that was measured, or a large point size, which might be 2, 4, or 8 points per pixels per point that was measured. On the point size down the bottom here, you can see on the left-hand side is a fine point size. On the right-hand side, it's a larger point size. The larger point size can sometimes look a bit more blobby. However, the fine point size, you might be able to see more data, but it may not be as visually appealing, or you may not be able to see all the data that you particularly needed. So changing the point size can become important. The sample region and intensity, this will allow the data to be shifted and downsampled. So you can sample by intensity will look at the color code or the grayscale intensity values, and you can select the data at a particular intensity range and then shift that to a new region. Sample by region allows you to select an area and say, I want to have a point every 0.1 of a meter, and it will create a new region where it copies those points into that new region based on your new selection set. So in the example on the right here, the sample by region tool has been used, and it's dropped the distance from the screenshot above, which is the same roundabout. We've just got a sampling of those points. This tool is very important for you for creating surfaces and things like that. It helps to minimize the number of triangles that are used in the surface generation and the amount of data that's going into it, and it may speed up those processes and produce a more desirable result. Another thing that sample by region can be used is, rather than sampling by a certain distance, a maximum number of points to be sampled can be used. And in this case, you can select data and shift it to a new region, and it will create a copy of that region based on the number of points you have selected. As mentioned before, there's also the filter station scan points, which will cut the data back to a certain radius from the station, which can be used to meet particular requirements for scan data. There's some view data options as well. In TBC, there's an option that's called See Inside. This allows you to hide all the points between where the scan setup is and the camera view in 3D view. The benefit of this is it allows you to see inside buildings, and it will hide the points in the view as you rotate around that are there, so you can see inside. If you don't have this turned on and it's just the view all data, you'll just see the back walls of that particular room, and you won't be able to see inside the data. It is worth noting, though, that if you have scan data side by side, if you've done internals and externals, this tool is referencing the difference between the scan station and the camera view. So you may need to turn outside data off to best see inside a building when using this option. There's also a station view, which allows you to look through the scan data as if you were looking through the station out in the field. This allows you to overlay the scan data against the imagery that was captured at that particular station. And when you're looking at the scan data through a station view, it allows you to turn on and off different regions. It allows you to digitize. You can see the data with the different intensity values, the different pixel sizes. All those options that are available to you in the plan and profile and plan and 3D view are available in the station views as well. There is also an option down the bottom in the station view. There's an icon that looks like a little funnel that allows you to turn on and off the ability to see all the data collected in the entire project, or just limit you to the data that was collected at that particular station. By default, it will show you the data that was collected at that particular station, and that's generally enough. However, if you wanted to see all the data within the entire project from that station, you can see that too. Cutting planes are extremely useful for slicing through data, but can also be used to help create projected surfaces in TBC, and there's a number of different options that can be used for cutting planes. They can be created at multiple different plane types: easting, northing, elevation, 2 points, 3 points, vertical surface from a linear path. And when looking at a linear path, you can even create subplanes. So you could draw a line, say, down the center line of a road, create a plane from a linear path. So you select the line that was down the middle of the road, and then in the subplanes tab there, you can actually create subplanes. So a plane every 1 meter through the cutting plane, so that you have a set distance along that line which you can digitize off. Anything in the cutting plane is the same as the other views, where you can digitize off it, create points and lines, and it can be used. The cutting plane can also have a position that's the default position, so that's the 0 value for the cutting plane. However, there is a slider along the bottom of the view that allows you to slide up and down the view to the axis that you are referencing to see different parts at that cutting plane. On the right-hand side, down the bottom, next to the left and right arrows, there's a little icon that allows you to also manually insert a subplane that you can reference back to later. Finally, for view handling, there is limit boxes, which this just essentially puts a box around the data at a certain point with some grabbers that you can use to expand or contract or shift around to allow you to just view the data in a certain area. Limit boxes can also be saved. So if you're using a large project, you can have multiple limit boxes that you can save and recall as you go through, and that can help with viewing and isolating particular parts of your data set as well. Other tools that there are in TBC, there's a smart picking tool. So when you use the create point option in TBC, there's a little icon to the right of the easting and northing fields. So on the right hand side of the screen at the top there's a smart picking tool view. There's a little cloud with a blue symbol next to it. If you select that, it opens the smart picking tool option. This means anytime that you create a point in your project now off scan data, it will open up a tiny little window, and in this particular case we have the face of curb option that is selected, and it creates a little cross section that you can then use to pinpoint the actual spot that you're looking for. It can sometimes be hard to identify a specific point when you're out of the scan data from a 3D or a 2D or another particular view. This just creates a little cross section that you can say, well, I want the bottom of the curb or the top of the curb. If you pick that point in that little validate picking option, what it will do then is that will be the coordinate that's used, and to ensure that you have selected the point that you're actually looking for. There's also the virtual DR option, which is in the bottom right hand corner of this view. This is the only way that you can create a new CAD point from the scan data that hasn't physically been measured. So what the virtual DR tool will do, and it can only be available when you've ticked this on, when you're creating a CAD point in the station view, is when you go to select that point, a little box will come up from the image behind. You can then create a CAD point from the image behind, and as long as there's scan data surrounding that point at a reasonable level, the TBC will manually calculate a CAD point for that particular spot and create the CAD point at that location. These are tools that the smart picking tool and the virtual DR tool are not creating a new scan point. They are creating a CAD point at that particular location. The smart picking tool will only use the nearest point in the scan data, whereas the virtual DR tool can be used to calculate a new location. There's also a tool that's create high-low, where if you select some scan data, it doesn't have to be from all the data. You could turn off regions and just select the ground, for example. Create high-low will identify the high and low point within the view and will return a high and a low point of that data. That can be saved as a CAD point within your project, or it can be just used as a general measurement tool. There's also a measure vertical clearance tool where it can be measured up or down, and you select a point and you can see the clearance between one scan data to another. So for power lines or for the height of a tree over a road, that can be used to identify the height or the minimum height in a certain area. There are several tools also for digitizing the point cloud. When digitizing the point cloud, we can use many different techniques. The very basic technique for digitizing the point cloud is actually coming from, say, SX10 data or SX series data, where it's actually captured in the field from the instrument itself as a total station point that comes in and is overlaid against your scan data, which can then be used for digitized. This is the easiest way of doing it. It's using field practices, and it's just overlaying the data to scan data. If you're physically digitizing the data from the point cloud itself, where you may not have used an SX series instrument, or you are using just general scan data, or even just imported point cloud data, it's worth noting that there are a couple of different tools that TBC has. There are some automated processes which are quickly expanding, and there's also some manual processes which are more like the traditional survey techniques that you would find being out in the field, where you create CAD points against scan data and give it a feature code. There are these multiple different ways are vast, and you don't have to use one technique within the scan data, you can use multiple techniques when processing the data. As a reminder, RealWorks should be used for creating 3D models, so most of these tools cannot be used in RealWorks, and TBC should be used for point and line work workflows. There are two ways to create line work from TBC. The physical line, so you can create a physical, this is manually creating the points. You could create a physical line using the line string tool, where you would give the line a name and define the layer, the color, the line style, and then digitize the data that way, drawing it around. Or you could manually create a CAD point and give that a feature code. The benefit for the different techniques is that you have a bit more flexibility in how you process the data. When using the CAD workflow, you're treating the process like a digital detailed survey out in the field, and it is a good way of relating it back to your existing your existing processes, and using your FXL for processing your feature codes as you would do normally. The other thing that you can do in TBC is use control codes to help import things, to help define things like curves, starting and ending of points, and those sorts of things in your feature survey to help process the data to get that high-end result. This is that automated processing or workflow where you're extracting the auto drafting function is another way of looking at it, where you're extracting the point and line and symbol work and getting that data to a point where you're really just tweaking the outputs to then digitize and send on. There are some different macros that are available for processing data. You can use the points to art macro for digitizing power lines, which can be downloaded via Rockpile Solutions. They have a whole heap of other macros as well. TBC has the ANZ Toolbox as well, which can be used for different tools for processing and handling different types of data as well. When specifically looking at the create CAD point and measure codes function in TBC, the create CAD point is, as mentioned before, is the easiest way of relating back to traditional survey practices. So points will be created. You can use them in creating these points with your existing feature codes. And then in TBC, when creating points, you can actually use the measure codes function, which is available in Access, to line up different types of codes and to allow quick digitization and moving up and down of strings as needed, relating again to what's been picked up in the field. Coding is done as the same way in the field, and when used, as mentioned previously, with control codes, you can get that high quality result, allowing you to process curves and start and stop lines as needed, and those sorts of functions throughout your data. The other tool that TBC has is the automated extract tools. There are two main ones, two categories of tools, and within there are a couple of different options. For the point extraction, it allows for extraction of trees, power poles, and signs. And in each case, from the point data, the information can be extracted to identify, say, a tree. So on the right-hand side here at the top, the tree has been identified, and we can identify the spread, the height, and the trunk width from just the scan data. This has not been captured in any way in the field outside of scanning. The system can automatically go through all the trees in your particular project, or you can manually select and identify individual trees to use in this case. When used with a feature code, you can then map the outputs to attributes. Those attributes can be stored against the point when you store it, and if you're creating symbols off that point, such as a trunk symbol and a spread symbol against that tree feature code, TBC will then do that as one single process, so you will be left with a trunk, a tree at their desired spread based on the information that's collected from the point cloud, and it will also allow you to store that information so that when you select that point, they will be stored as attributes against that point. The same for power lines and poles and signs. With power lines, we identify the height and the diameter of the power line, and that information can be stored to quickly allow you to capture that information from just the point cloud. There's also the extract line feature tool, which is being expanded and used currently in TBC. There are two main options in this tool, the extract overhead lines and the curb and gutter function. For curb and gutter, you can extract a minimum of 3 points and a maximum of 8 points in a project, and what it will do is you set up a cross-section, you identify the points in that cross-section you want it to track through, you identify the interval between each of the cross-sections that you're looking for, and also the tolerance. So you're looking at how close it needs to be before it will stop running the function and ask you what to do next. Within the curb and gutter function, as I mentioned, you can do a minimum of 3 or you can do a maximum of 8 points, and it does not necessarily need to be limited to curb and gutter. You can use it for anything that would have some form of profile that you would need to track through a system. For the power lines, it's the same sort of function. You can either manually identify each power line you want to track, or you can select one power line, and there is a tool that allows you to identify all the power lines in a certain area, and then it will track each of those power lines, resulting in line strings following the scan data. Another thing with the power line function is that you do not need to do each individual sag. You might have 10 sags that you need to track, so you would start the function at the first power pole, and you would finish the function at the 11th power pole, and it will track all those 10 sags all the way through. The line extraction is separate to the point extraction, so it's not picking up the power poles, but it's relatively easy to do that as a secondary process. At each step, when it doesn't identify where it's going next, so in both overhead lines and curb and gutter, you are given a set of options that allow you to say what you want to do next. So whether you want to stop processing, you want to look at changing the profile or select the next point. For curb and gutter, it will track around a corner in most cases, as long as the data is there. In both cases, though, it's recommended to have a good quality scan data that it's tracking through. Once the system has identified automatically the line work that it needs to extract, the option is given to put those lines on individual layers, which can then be drawn and saved against the CAD layers within your project. Once you've processed all that data and you've got your line work out and you've cut the data back, further tools in TBC can allow you to create surfaces and contours, for example. You can create a surface from any collection of data. It's recommended to run the surfaces function after you've processed the data. Surfaces should be generated, again, once the line work has been created, to allow that line work to act as break lines in TBC. The way that TBC handles break lines is that if the data has been created from an FXL, there is an option in that FXL feature code or in your feature codes that allows you to say you want it to be included in the surface or not. So for something that you don't want to be included in the surface, an example of that would be a pipe that has been collected under the ground in the bottom of a pit. You don't want that to impact on your surface, but you still want to create the line that where that pipe has been, where that pipe is heading. That can be automatically determined so that if that's turned off, it will not be used in the feature code in the surface generation. Otherwise, it will be used in the generation of the surfaces, and any line work that is manually created in TBC, if it's selected when the surface generation tool is used, then it will be used in that surface. If the line is not selected, or if the line is determined in the FXL as not being included in the surface, then it will be ignored and will have no impact on that surface. Considerations should be made about the resolution for the surface. So when looking at the density of point clouds, having a one-to-one representation of the scan data to the ground, to the surface, is not necessarily desirable. You end up with a lot of triangles. A lot of triangles start to have problems because of the way that the surface is generated due to over points that are right up against each other, points that are measured underneath other points. So it's always recommended to downsample the data to a reasonable aspect to give you a nice quality surface at the end. When looking at creating surfaces, the same actually when looking at handling point cloud data in general in TBC, it does not need to come from Trimble data. It does not need to come from a Trimble instrument. It can come from imported data, so UAV data imported from from say Pix4D, or scanner data from other scanning packages can be imported, and all these functions can be used against them in TBC. When looking at creating surfaces, the data does not distinguish between data that has come from a Trimble environment. It can be used for anything. Once you have created the surface, you can create contours off that surface, and there's quite a lot of options for creating contours within TBC, and also TBC RealWorks can create surfaces as well. When you're finished, there are different things that you can do. So what do you do generally with finished data? So generally you could print the data out. So you could create drafting plans in TBC. There's a full drafting package underneath to allow you to handle proformas, digitize, create drafting sets, and print and plot the data out. Linework can be exported to CAD and used moving forward from there. So if you're more comfortable using the data in a CAD environment such as AutoCAD or MicroStation, or if you're, the data is needed in those particular formats, the export function in TBC supports all major formats, so it can go out to those particular formats as needed. Point clouds can go to specific point cloud functions, formats, to be handled in other packages as well. There's also a point cloud viewing tool that Trimble has called Clarity, which the point cloud data can be uploaded into Trimble Clarity, and then a link can be shared to other users for viewing that data through a web browser. There is a little bit involved with setting that up and making it work. However, the option is there and available. Orthophotos can be generated from top down or from any of the cutting plane views as required, and also panoramas can be extracted as well. Along with this, there are many other different ways that you can export the data, and TBC will generally be able to handle most of them, and RealWorks will be able to handle a significant number of those, as well as other ones as well. So the recommended process for handling scan data once it's come into the Office environment. First off would be to import the data. Then you would register the scans if you need to, depending on the type of data that's come in. You could then georeference the data into its correct location. At this point, I would also look to import any other additional data sets from external sources that might be required to enhance the data. Of course, you can add to projects as you go through. So again, don't feel that this is a hard and fast rule for processing the data. It's just a recommended process. Once you've done this step, I would recommend processing the panorama and then colorizing the scans. If it's been colorized on import, I would recommend running this step again. So for the X7 and the TX series instruments where it needs to be done on import, I would run this process where you process the panoramas and then recolorize the scans with those processed panoramas to help add to the quality of those general outputs. I then create and tidy the regions, so classifying those regions, making sure the data's on the correct regions and in the correct location as needed. It doesn't need to be to the nth degree or to be exactly correct. It generally just needs to make sure that you've got the data basically in the regions for what you need it to be when processing. And you can change the regions as you go through a project. So if you notice some data that should be on another region as you're digitizing, you can always make those edits as you go through. Once you've classified the regions, it's then easier to generate the CAD data because you can turn off, say, the default region and get down to the specific data that you're looking for to allow you to process that CAD line work. This CAD, generating the CAD points and line work can be done simultaneously or independently to the extract point cloud features. There's no one or the other tool. You can do one and then the other and then flip backwards and forwards as needed. So don't feel you have to do it in that specific order. It's just I would generate the CAD points to begin with, and then finish off with extracting the point cloud features at the end. I'd then create the surface and line work, so that would be recommended after you've done all of this. So while you can generate a surface at any stage, and you may want to generate surfaces early on just to check the quality of the data that's come in, or do some general checks, or view the data in some way, shape or form, it's recommended to create your final surface after you've created your line work, because the point and line work will have an impact on those surfaces. When generating the surfaces, remember that the surfaces are generated from all the selected data. So if you have things in those surfaces that you don't want, if you have things in your project that you don't want, then you just simply would not have them used when creating the surface. There are also tools when creating once you've created the surface, that allow you to add and remove points. So if you went back and digitized some data afterwards, you can add them to your existing surface. You can remove points that are creating spikes or holes in your surface as well. You can also edit the data and recalculate the surface. So once a surface has been generated, it is still an active surface against the data in your project, which there are several tools that you can use to add and remove from. Tidy up underneath buildings and around edges for your surface, so you can actually cut the surface back if needed. You can also create holes in surfaces underneath buildings if you wanted to. There is no set limit to the tools that you can use within surfaces. Once the surface has been created, there's all sorts of tools that can be used to edit and tweak the surface to get the desired outcome. Once the surface has been finalized though, I'd then generate the contours, and then once the contours have been done, it's time to publish out to the desired format. Thank you for listening to this presentation. Hopefully the three presentations together, or this particular presentation, has been useful. If you want more information on scanning projects, or if you have any queries, please contact UPG on 1800 800 874. Thank you.